So today we are going to be graphing functions and find the domain and range. So our learning targets here to graph functions by first making a table of ordered pairs. Then we're going to determine if a graph represents a function, and then we're going to find the domain and range of a function's graph. So let's start here by first graphing by first making a table of values. So to do so here, we have the function x squared minus 3 here. This x squared up here is going to make a parabola. That's the shape of the graph there. Because you've got an x squared in there, you should know that it's parabola shaped. So when we graph it out on the graph, that's what we should have for a shape. Otherwise, we've done something wrong in our table. So some nice table of values here to pick are -2, -1, 0, 1, and 2. So those are just nice values to typically pick, especially for a parabola here. So go ahead and take your -2 and plug it in there for your x. So -2 squared minus 3. -2 squared is -2 times -2, which is 4, minus 3 is 1. Now take -1 and plug it up there in for your x. So -1 squared minus 3, which is 1 minus 3, which gives us a -2. Now let's try 0. So 0 squared minus 3. So 0 squared there is 0. Minus 3 is a -3. Now let's plug in 1. So 1 squared minus 3. 1 squared is 1. Minus 3 is a -2. And then lastly here, let's take 2 squared minus 3. 2 squared is 4, because 2 times 2 is 4. And then minus 3 is 1. So now we have our table, so let's go ahead and plot those. So our first order pair is -2, 1. So I'm going to go over -2 and up 1. Then my other order pair here is -1, -2. So I'm going to go over to the left here 1 and then go down here 2. Then I've got 0, -3, so I can just go straight down 3. And then I've got 1, -2, so over to the right 1 and down 2. And then I'm going to go 2 to the right here from 0, 0 here and up 1. Once I have those, make sure you connect the points so it looks like a graph. Don't just leave the dots on the graph. Go ahead and connect the points as well. So notice the shape here is a parabola, just like we said it was going to be a parabola over here because of this x squared in here. So let's try another one here. We're supposed to graph out this one. Now this one here, hopefully you remember that this is going to be a line. Why is it going to be a line here? Because it's in that form of y equals mx plus b. When it's in that form there, we know it's going to look like a line. Over here on the side here, they've told us what values here to pick for x. We're supposed to pick from -2 to 2. So let's do that. -2, -1, 0, 1, and 2. We're not supposed to go beyond this -2 and this 2. Those are important. Minimally, we want to pick the points -2 for our x and 2 for our x, those two x values, and then we'd have to find the y values to go with it. Let's go ahead and let's plug in -2 in here. So 3 times -2 minus 1. 3 times -2, there is -6 minus 1. Notice I'm following the order of operations. I have to multiply before I subtract. So we get a -7. Now let's go ahead and let's substitute -1 in there. So 3 times -1 there is -3. Minus 1 is a -4. Our next one here, 3 times 0 minus 1. 3 times 0 is 0. Minus 1 is a -1. Our next value here, 1. So plug in 1. So 3 times 1 minus 1. 3 times 1 is 3, minus 1 is 2. Again, following the order of operations, we multiply and then we subtract. So 3 times 2 minus 1. 3 times 2 is 6, minus 1 is 5. So now let's go ahead and plot this and know that we have to have a line when we're done with this. So -2, -7. And then -1, -4. 0, -1, 1, 2, and 2, 5. Connect my points. Notice I'm not going to go beyond the 2 endpoints of the graph here because The reason why I'm not going to put arrows on these is because it specifically said to pick values from -2 to 2. So we're just going to have what's called a line segment. If you remember that term, they're from geometry. So now we have another graph we want to do here. This says graph each function by first making a table of values, and our function here looks like it's a square root function. Now this one's a little bit more particular here because you want to take what's underneath your square root there and you want to set it to 0. You don't want to pick -2, -1, 0, 1, 2. So if I take this and set it equal to 1 here, set it equal to 0 here, I can now solve for x. So I end up there getting x equals 1. So we're going to start this one here at 1. So once we have that, you can pick either value smaller than x or larger than x. If I were to pick it smaller than x, such as 0, 0 is smaller than 1, and plug it in there, 0 minus 1, what does that give me? A -1. Can I take the square root of -1? No, I cannot take the square root of a negative value. I'll get an error on my calculator. So when I pick values that are larger than 1, so for instance here, I'm going to pick 2. If I plug in that one, I'm going to go 2 minus 1 is 1, and the square root of 1 there is 1. And I also have to go ahead and substitute the 1 in up here. So 1 minus 1 there is 0. The square root of 0 there is 0. All right, now you have to pick some other values here for x. So something may be larger than 2. You could pick 3, but 3 minus 1 there is 2, and I can't find the square root of 2 that I get a nice integer. I'm going to get some decimal answer. If you prefer now just picking 1, 2, 3, 4, 5, there's nothing wrong with that. But I'm going to pick values I can actually find the square root of. So for instance, 3 minus 1 is 2. I can't find a nice square root of 2, so I'm going to pick 4. 4 minus 1, nope, that's 3. I can't take the square root of 3 and get a nice value. What about 5? 5 minus 1 is 4, and I could find the square root of 4. That would be 2. So those are just nice integer values that I'm getting out there for y. Do you have to pick those? No, like I said, if you wanted to pick 1, 2, 3, 4, 5, that would work as well. 6, no. 7, no. 8, no. 9, no, that'd be square root of 8. What about 10? Yeah, 10's going to be a nice one. 10 minus 1 there is 9, and I could find the square root of 9. It's 3. So then what's my next value I can actually take the square root of? It'd be 16. So 17 minus 1 there is 16, and the square root of 16 there is 4. So now I can plot those values. 1, 0, 2, 1, 5, 2. And then I've got 10, 3. I'm going to connect those. And a square root graph always looks like that. It looks like half of a sideways parabola. It might be going in different directions, but that's what it's going to look like. It could even be upside down, but that's what it's going to look like when you graph it out. Our next function here is an absolute value. What does an absolute value graph look like? It looks like a V-shaped graph. This one here, if you could go ahead and pick just the values -2. That's what we're going to do. -2, -1, 0, 1, 2. Those will work with ones that we're going to do for this time. We'll get more specific later on when we graph some absolute value functions. But for now, -2, -1, 0, 1, 2 will work. So let's plug those values in there. So 3 times -2. Again, you want to take care of what's underneath the absolute value there first. You get -6, and then whatever comes out of there has to be positive, so we get a +6. Our next one here, value to plug in, is -1. 3 times -1 there is -3, and then the absolute value of -3 there is 3, because whatever comes out of the absolute value is going to be a positive value. Let's go ahead and let's plug in 0. Absolute value of 3 times 0, so 3 times 0 there is 0. Absolute value of 0 is 0. Go ahead and plug in 1. So 3 times 1 is 3. Absolute value of 3 is 3. Whatever comes out of the absolute value after you get it all simplified down has to be positive. And then 3 times 2 is 6. Absolute value of 6 is 6. So now just go ahead and plot that. Negative 2, 6. 1, 2, 3, 4, 5, 6. Negative 1, 3. 0, 0. 1, 3. 2, 6. Connect your points. Notice when I'm connecting them, we said it was going to look like a V, and there it's looking like a V. Graph this set here. We've got f of x there equals negative 1. Now, interesting enough here, if you remember f of x there, that's just saying that your y values are all negative 1s. There isn't an x to plug it in there for, so what comes out of this is all going to be negative 1s. You can pick whatever x values you want because there isn't an x in here, so I can pick negative 2, negative 1, 0, 1, 2. Could you have picked 1, 2, 3, 4, 5? Sure, that would have worked as well. Or 0, 1, 2, 3, 4, that would have worked as well. So let's plot this. Negative 2, negative 1, negative 1, negative 1, 0, negative 1, 1, negative 1, and 2, negative 1. It just ended up here with a nice horizontal line. Oops. And then I can put arrows here at the ends. So whenever you have just f of x there equals just a numerical value there, you're going to end up there with a horizontal line. I'm going to clean this up a little bit because it's not looking very nice. There. All right, so then our last piece here is to look here at domain and range. So let's do that. So looking here at domain and range, it says input and output. So your domain here is your input values or your x values or your independent variable. So when we're looking here, we're going to be looking left to right. And we're going to be looking at the x values. When we're looking at the range, that's your output values or your y values or your dependent variables, you want to look bottom and then top. And we're going to be looking at the y values when we do that. So example 2 says, determine whether the curve is a graph of a function and then state the domain and range. So if we're going to go through all these, we're going to go through A, B, and C here and just look at whether it's a function here first. So what you want to do here is you want to kind of think in your head here. I usually take like a pencil and go through my graph here and see if it's passing through one point at any given time. So if I kind of draw lines in there, it's only going to pass through one point at any given time because this is a nice curve. So this one here is, yes, it is a function. And you can say yes, or you can say no, or you can write function and then not function. It's up to you. So again, I could take a line here, a vertical line here. It's only going to pass through one point at any given time. So yes, this is a function. What about this one here? If I take a line here and I pass through, it's going to be passing through this point and this point at the same time. So this is not a function or no. All right. So then the next part here is we're supposed to state the domain and range. I like to use parentheses and brackets when I do this. So I'm going to look to the very leftmost for my domain here. You're going to, like it says up here, like I wrote up here, you're going to look left to right. So what's the leftmost point here? The leftmost point here is this one right here. What's the rightmost point? The rightmost point is over there. So what's the x value of this leftmost point here? Well, the x value over here is sitting there at 1, 7, it looks like. So the leftmost point there is 1. So you do a bracket. And then what's the rightmost point over here? It's sitting over here at 5, 7. So the rightmost value there for x there is 5. So from 1 to 5 for your domain. What about the range? That one there, we said we're going to be looking here from bottom to top. What's the bottommost point? This one down here. What's the topmost point? You can pick either one of this, either 1, 7 or 5, 7. It doesn't matter. So the bottommost point there is sitting there at, looks like 3, -1. And so at 3, -1. So what's the y value down here? It's at -1. What's the y value up here? 7. So from -1 to 7. All right, so let's come over here and let's look at letter B. Domain and range. So domain, range. Again, domain here, we're going to look left to right. What's the leftmost point over here? This one over here. What's the rightmost value? Rightmost point there? It's over there. So what's the ordered pair here? This is sitting here at -2, -8. What's this one here sitting here at? 2, 8. So what's the leftmost point's x value? That would be there at -2. What's the rightmost? That would be at 2. So we're going to put brackets, and we're going to say -2 to 2. Don't use parentheses, use brackets because it includes those values. All right, so then let's look at the y values. So range here, we're talking about the y values. So what's the bottommost? It's down there. There's my bottom. And what's the bottom y value? -8. At the top, where's the top? It's up there. What's the topmost y value? It's at 8. All right, and then letter C, because it's not a function, we don't have to state the domain and range. Let's come down here and let's look at D, E, and F as well. So letter D there. Is that a function? So again, I can take a pencil here or whatever, pen, and it's only going through one point at any given time. So yes, this is a function. And this time I'm just going to say yes. What about letter E? If you take a line, a vertical line, and you go through this, it's only going through one point at any given time. So yes, this is a function. And what about this one here? As I take a vertical line and I go through these, it's only going through one point at any given time. So yes, it's a function. Now, all we have to do here is find its domain and range. All right, so our first one here, remember we're going to look left or right for domain. What's your leftmost point? Right here. What's my rightmost point? Right there. So let's name the ordered pairs here, the values here. So this one here is sitting here at -2, -10. And this one over here is sitting here at 3, 0. All right, so the leftmost x value there is -2. What's the rightmost x value? It's sitting over there at 3. All right, now we have to look at the y values. So the y values, we're looking at bottom to top. What's your bottommost y value? This is my bottom, so that's -10. Where's my top? My top is actually here. So what's that value there sitting there at? It looks like -1/2 and 1 is what I'm seeing. So what's my topmost y value there? It's sitting up there at 1. Letter E here. Again, domain and range. So what's my leftmost x value? Sitting over here. That is there at -3, and it looks like -4. What about this one over here? That looks like it's 15 and then -4. All right, so for this one here, we're looking at the leftmost x value there, which is -3. What's my rightmost x value here? That would be there at 15. All right, range is bottom to top. So my bottom looks like it's sitting right there, and that value there looks like it's there at 6, comma, -6. So the y value there, the bottommost, is -6. What about the top? Well, I can either pick this one here or this one here. And what's the y value of either one of those? It's there at -4. All right, what about letter F? Domain, range. So this one here, we're looking at that value right there. So, and we're looking at, that's the left, and this one here would be my rightmost. So what's the x value there? Now this one's a little bit harder to see here, so it's looking like, I would guess that that's -23. And then it looks like it's up there at 9. This one over here, closer here to 6, I'm going to say -5, and then it's up there at 8. So if we do our x values here, leftmost x value there is -23, rightmost there is at -5. What about range? That would be bottom to top. What's my bottommost point here, and what's my topmost? Right there. So this is -18, and then they're at 4. This one over here is at -9, and then up there at 12. So y values, the bottom one there is 4, and my top one there is 12. Now, notice I put the wrong kind of symbols around it. It's supposed to be brackets, not parentheses. So I need to change those because those are solid dots there. You'd use the parentheses there if those were open dots at those spots. But because they're solid dots there, we're going to use brackets. Or if the graph there just goes through it, you use brackets. So our last few here, input values, x and independent. So, and then range there, remember bottom to top, that's your y values. So again, determine if these are a graph of a function or not. So if I look here and if I take a point here and a line here, a vertical line here, I'm only going through one point at any given time. So this is indeed, yes, this is a function. What about letter B here? If I take a vertical line here and I'm only going through one point at any given time, yes, that's a function. And then this one here, I'm only going through one point at any given time here, so yes, this is a function as well. All right, so looking at these here, again, you want to find the leftmost point and the rightmost point. Well, for the domain, if I look at the leftmost point here, there's an arrow here at the end here, and that's going to the left forever and ever and ever. So what that means is to the left there, we're going to use a parenthesis. That's -infinity. So you do negative, and then you do a sideways 8. And then if I look to the right over here, this has an arrow here at the end as well, so it's going over there to the right forever and ever and ever. So we're going to say infinity there as well. And we're going to use parentheses when we do that. Now we're going to look here at bottom to top. At first here, we might think that this here is my bottom, and at first we might think that this here is my top up there above that curve up there. But because I extended these up here, you can see these are going up. If I were to extend those up, you can see that those are going up forever and ever and ever. The bottom here is here, and then we're going up forever and ever and ever. So the bottom there is there at 0, and we're going to do a bracket, and then it's going up forever and ever, so that's infinity parentheses. So bottom to top. All right, what about letter B here? What's my leftmost point? Well, my left here is going forever in that direction, so that's negative infinity. So again, use parentheses when you've got infinity and negative infinity. And to the right here, I've got infinity as well. What about bottom to top? Well, my bottom here, I'm going down forever and ever, so that's negative infinity. What about top? My top is my y value up here, and that's sitting there at negative 2, 1. So my top value there is 1, and I'm going to use a bracket with that because it's a numerical value and there's not an open dot there. Letter C, let's look at domain and range here. Domain here, I'm looking at the left. The left here is here, but it's going to the left. It looks like it's just going straight down, but it's actually going to the left as well, so that's negative infinity. And this one here is going up and to the right forever and ever, so that's infinity. What about the range here? That's bottom to top. So my bottom here, it's going down forever and ever and ever. That's negative infinity. And then my top here is going up forever and ever and ever, so that's infinity. So this should be a negative infinity there. I'm going to erase this and rewrite this. So this should be a negative infinity, infinity. So you now get to work on the 1-2 worksheet.